Very good morning, student. Last class we discussed regarding the coordination compound, especially the terminologies involved in order to understand the coordination compound. Everything we discussed in the last class. In this class, we are going to deal with IUPAC nomenclature. What is this IUPAC nomenclature? For example, in this chemistry, whatever it may be, whatever the compound it may be, once one compound is there means name also very important. Correct no? For example, ee kade one kade certain area dalli specific compound na prepare madidre without name, it is highly difficult to analyze and understand their behavior. In order to avoid the confusion, IUPAC nomenclature is very useful to us. What is this IUPAC nomenclature? Here, you know coordination compound. First, once again, I am going to repeat what is this coordination compound. See, coordination compound means, especially in this compound, metal and the ligand, they are held together by coordinate bond. For example, see, within the square bracket, this one is simple ion and this one is complex ion. This one is coordinate. Here coordinate bond we can observe. This is simple ion and this one is complex ion. See, listen here. Here only one iron is there. Around one iron, 6 Cn. Cn means cyanide. Cyanide ions are surrounded. What it indicates? The bond representation also little bit different. Normally, NaCl means we will represent like this, NaCl. It's nothing but ionic bond. Haudalva? Ionic bond andre sodium matte chloride madhye eradu charges madhye, positive negative madhye, just one line hakidre it's nothing but ionic bond. But see the difference here. Arrow mark yav kadegide? Iron kadegide. What it indicates? It indicates Cn donate the pair of electron towards metal deficient iron. You know, metals are always electron deficient species. Here, iron is a metal, no doubt in that, D block element. Iron is electron deficient, so Cn is electron rich. How you come to know? Cn minus, we always represented as Cn minus. Cn minus donate the pair of electron towards electron deficient iron. See? This entity is closed by square bracket. This is complex ion. Whether it may carry positive charge or negative charge. In this session, we are going to deal with the namings. How to name that? What are all the rules we have to follow? Everything we will discuss in this topic. Now, first basically, coordination compound means mainly it contains central metal atom, ligands, counter ion, everything. First, you should know. For example, if I am using Cn as a ligand means, what name we will give for that? You know, ligand, two types of ligands are there. First one, neutral ligand, and second one, anionic ligand. What are all the examples for neutral ligand? First one, what do you mean by neutral ligand? Neutral ligand andre enu? The name itself indicates neutral. Neutral means there is no charge. No charge means there is no positive, there is no negative. But it contains mainly lone pair of electron. For example, NH3. What is this NH3? Ammonia. Here any charges are there? Positive, negative, nothing. But it mainly contains lone pair of electron. Which one? Nitrogen. Nitrogen contains lone pair of electron. That's why ammonia is a neutral ligand, no doubt in that. ಏನಂತ ನೀವು ಯೂಸ್ ಮಾಡಬಹುದು ಅದಕ್ಕೆ? amine. Suppose if I am using ammonia as a ligand means I should use the name amine. And second one, you know H2O. H2O is nothing but water. But in coordination compound, I can't use water or H2O as it is. Instead of that, I should use aqua. And you know one more very important, En. What is this En? En means ethylene diamine. Ethylene diamine. En means ethylene diamine. What is the formula for En? CH2, CH2, NH2, NH2. Here, the name itself indicates the presence of two carbon atoms. Ethylene, eth means you know it contains two carbon atoms. 1, 2, two carbon atoms. Diamine means each carbon attached to one nitrogen. Two carbons are there, so two nitrogen. Amine group, NH2 group. So, ethylene diamine. Ethylene diamine means two carbon atom and two NH2 groups. Ethylene diamine. But in formula, we can't use full. It's highly difficult to use the right as it is. CH2, CH2, NH2, NH2. It's highly difficult to represent as it is. So, in order to avoid the confusion, I am going to use En. Simple form. But this one is normal one. In IUPAC, we will represent like this. Ethane 1,2 diamine. Why ethane? Because two carbon atoms are. So, ethane 1,2. See, you know, in IUPAC nomenclature, instead of normal things, first we should assign the numbering 1, 2, 3 parent chain. First we should select the parent chain. Here parent chain contain only two carbon atoms. For the first carbon atom, one amine is there. For the second carbon atom, second amine is there. So 1, 2 diamine. And CO. CO means one carbon, one oxygen. Here also no charge. But what is the name for this? For this, carbonyl. And last one, NO. NO means nitrogen, oxygen. What is the name for NO? Nitrosyl. These are all few examples for neutral ligand. Here you can observe, in all the cases there is no charge, there is no positive, there is no negative. Here see NH3, ammonia. But in IUPAC, according to IUPAC nomenclature, we should use as amine. And H2O, water, aqua. En is nothing but this is the formula for En, ethylene diamine. But in IUPAC, we should use ethane 1,2 diamine. And CO is nothing but carbonyl. And NO is nothing but nitrosyl. This is regarding the neutral ligand. But what about the anionic ligands? Anionic ligands. See, here it never contains any charge, but it contains lone pair of electron. But here it mainly contains negative charge. That's why anionic ligand. What are all the examples for anionic ligand? ONO minus. ONO is nothing but NO2 minus. NO2 minus, you know, NO2 minus means nitro. NO2 minus means nitro. But here ONO2, what is the difference between NO2 and ONO? Here both are same, but here nitrogen will donate the electron, but here oxygen is mainly responsible for the donation of electron. You know, ambidentate ligand. Ambidentate ligand andre you know, both contain the electron, but at the particular point only one atom or one group will donate the pair of electron. That is ambidentate ligand. Here this one is nitrito. And next one, this is NO2 minus. What about NO3 minus? Suppose one more oxygen will add up, means what happened? NO3 minus. This is nitrito, this one is nitro, and this one is nitrato. Suppose OH minus, you know that. OH minus means hydroxyl ion. Or else, if OH minus we are using as a means, what is the name for that? Hydroxo. Suppose O2 minus, O to the power 2 minus. 2 minus means oxygen containing 2 negative charge. Then we will use as peroxo. Suppose O2 minus, O2 minus, this one is O to the power 2 minus, but this one is O2 minus. What is the name for that? Oxo. You know, just now I explained about the Cn minus. Cn minus means that is also ligand. What is the name for the Cn minus? Cyanide group. Cyanido. Suppose Br minus means halogen. It may be bromine. It may be chloride. Means charges are there. We can't say bromine, chlorine. Bromine means Br2. Bromide ion or chloride ion. If we are using bromide ion, chloride ion or else iodide ion as a ligand, then what is the name for that? Bromido. And Cn minus means, this one is bromido, means Cn minus means chlorido. And next one, CH3COO minus. This acetate ion also, acetate ion in organic chemistry, especially this one is nothing but acetate ion. But in coordination, we call it as acetato. Acetato. What is this acetato? Means it's nothing but acetic acid. What is the formula for acetic acid? CH3COOH. You know, CH3COOH is an acid. What is the characteristic of acid? Acid means any species it donate H plus, we call it as acid. Here also it will donate H plus, CH3COO minus and H plus. Once any species donate H plus, we treated such type of species as an acid. Here also CH3COOH donate H plus means it's nothing but acid. That's why what is the name for this? Acetic acid. Here it's contain negative charge. Negative charge means anion. It serves as a ligand. Suppose it serves as a ligand means what is the name for that? Acetato. And last one, COO minus, COO minus. It's nothing but oxalic acid. COOH is nothing but oxalic acid. If I remove 2H plus, then what happened? This become oxalato. Oxalic acid become oxalato. Just observe one thing in all the cases, for example here, in all the cases, the name end up with O. Nitrito, nitro, nitrato, hydroxo, oxo, peroxo, cyanido, bromido. Means in all the case, the name end up with O. It indicates species carrying negative charge. But just observe in this case, here there is no O. Illalladru O idya? Illa. Amine, aqua. In all the case, it's not end up with O, but here in all the case, anionic ligand, especially anionic ligand, it's end up with O. That is one of the thing. And next one. Now, okay, let it be. You know, in coordination compound, we are going to classify based on the charge. What charge? If the coordination space is carrying positive charge, that is cationic complex. If the coordination space is carrying negative charge, anionic complex. No charge, neutral complex. Correct na? That one. And next one, in anionic complex, the metal name we can't use as it is. In neutral and cationic complex, we will use the metal name as it is. For example, iron means iron only. Silver means silver only. Correct no? I will explain wait. Now, metal symbol and the name in anionic complex. And the name in anionic complex. Name in anionic complex. See, for example, now if I am using iron as a central metal atom, CMI. CMI means central metal ion. For example, if I am using iron as a central metal ion. What is the formula? What is the symbol? So not formula. What is the symbol for iron? Fe. But the name of iron in anionic complex. Anionic complex means the complex carrying negative charge. The name we can't use iron as it is. Instead of that, we should use ferrate. We should use ferrate. Suppose the central metal ion, if it may silver. What is the formula for silver? Ag. What is the name of silver in anionic complex? Argentate. ಎಲ್ಲಿಂದ ಬಂದಿದೆ ಈ ವರ್ಡ್ ಎಲ್ಲ? Mainly from Latin. And suppose if I am using platinum. What is the symbol for platinum? Pt. It's nothing but platinate. Suppose if I am using tin, symbol for tin, Sn. Name of this tin in anionic complex become stannate. What are all the other metals generally we are using? For example, iron over, silver over, platinum over, tin over, palladium, symbol for palladium, Pd, palladinate. Suppose if I use chromium, symbol for chromium, Cr, chrominate. Means the name end up with ate, 8. The name end up with 8. See, iron become ferrate, silver become argentate, platinum become platinate, tin become stannate, palladium become palladinate, chromium become chrominate, gold become R8. What is the symbol for gold? Au. It become R8. This is regarding ligand. This is regarding central metal atom, especially in anionic complex. ನಾವು ligand ಅಲ್ಲಿ ಬೈಫರ್ಗೇಟ್ ಮಾಡಲ್ಲ. anionic complex ಅಲ್ಲಿ ತರ ಯೂಸ್ ಮಾಡಬೇಕು, cationic ಅಲ್ಲಿ, neutral ಅಲ್ಲಿ ಅಂತ ಯಾವುದನ್ನು ಬೈಫರ್ಗೇಟ್ ಮಾಡಲ್ಲ. ಬಟ್ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮಿಕ್ ಬಂದಾಗ anionic complex ಗೆ ಬಂದಾಗ ಮಾತ್ರ ಈ ತರ ನೇಮ್ಸ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. In all the remaining cases, name as it is. For example, cationic complex neutral bandre iron iron age irutte, silver silver age irutte, silver argentate agi badlagalla. But in anionic complex, silver become argentate. Confuse agadi idralli. And next one, in order to understand that coordination compound naming na tilkoloko first certain rules are there. Certain rules means how to name for neutral complex, how to name for cationic complex. That too for homolyptic. First thing, you know two types of complex, homolyptic, heterolyptic. Homolyptic means same type of ligand. Homolyptic means same type of ligand. Same type of ligand. That is homolyptic. Hetero means opposite. More than one type of ligand. Heterolyptic. Means more than one type of ligand. More than one type of ligand. Now first simple one, homolyptic. Iವಾಗ homolyptic ಗೆ ಯಾವ ತರ ನೇಮ್ ಮಾಡೋದು ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. Next we can discuss the heterolyptic complex. First, how to name for homolyptic complex. Suppose in homolyptic, neutral means how, cationic means how, anionic means how to name that. What are all the rules? First one, suppose if the complex is neutral. Neutral complex. If the complex is neutral complex, how to name that? First, you should, neutral means there is no charge. Charges iralla means counter ions iralla anta. Neutral complex ಗೆ ಯಾವ ತರ ನೇಮ್ ಮಾಡೋದು? First, how many ligands means number of ligands na count ಮಾಡ್ಕೋಬೇಕು. First, number of ligand. Next, after number of ligands, for example 1, 2, 3, 4, 5, whatever it may be, how many ligands are there? Just mention the number of ligand, presence of ligand. Next, name of the ligand. Name of ligand means what is the name for the particular ligand? It may be amine, it may be aqua, whatever the ligand. Here so many ligands are there, no? Means first how many ligands are there, then after that what is the name for the particular ligand, then after that CMI. CMI means central metal ion. CMI means central metal ion. And after that, what is the oxidation state? Oxidation state means loss of electron. How many electrons are lost? What is the charge of the central metal atom? That one you should calculate. Oxidation state of CMI. This is the rule to name for neutral complex. Then what about for cationic complex? Cationic complex. How to name for cationic complex? What are all the rules? First one, same as it is. Number of ligand, name of the ligand, central metal ion, oxidation state of CMI, but only one extra counter ion, because this cationic complex ಅಂದ್ರೆ ಏನು, ಕಾಂಪ್ಲೆಕ್ಸ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇರುತ್ತೆ, ಅದು ನ್ಯೂಟ್ರಿಫೈಡ್ ಮಾಡಬೇಕಾದ್ರೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್, ಸಿಂಪಲ್ ಅಯಾನ್. ಸೊ ದಟ್ ಈಸ್ ಕೌಂಟರ್ ಅಯಾನ್. That is counter ion. This is regarding cationic complex. Now, for example, that is anionic complex. How to name this? Anionic complex. How to name this? Now, anionic complex means complex carrying positive charge. negative charge means the simple ion carrying positive charge. Positive charge always first, na? That's why counter ion first. Counter ion. Then same trend will follow. Number of ligand, name of the ligand, central metal atom, CMI, last one oxidation state of CMI. Understood? This is clear now. See, in order to understand this IUPAC nomenclature, first you should know all those things. First, you should know which one is neutral ligand, which one is anionic ligand or else negatively charged ligand, and adardu name, ಏನಂತ name ಮಾಡಬೇಕು. Negatively charged ligand ಆದರೆ it end up with O. And then metal name, especially in anionic complex, ಯಾವ ತರ metal name change ಆಗುತ್ತೆ? Ferrates, argentate, arate, chromate, palladianate, ಯಾವ ತರ change ಆಗುತ್ತೆ? It end up with ATE. And next one homolyptic complex na ಮತ್ತೆ heterolyptic complex ಅಂದ್ರೆ ಏನು? homolyptic ಅಂದ್ರೆ metal ಸುತ್ತ ಇರೋ ಎಲ್ಲಾ ligands ಸೇಮ್ ಇರುತ್ತೆ. ಸೇಮ್ ಅಂದ್ರೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ CN ಯೂಸ್ ಮಾಡಿದ್ರೆ ಎಲ್ಲ CN ಇರಬೇಕು. BR ಯೂಸ್ ಮಾಡಿದ್ರೆ ಎಲ್ಲ BR ಇರಬೇಕು. Cl ಯೂಸ್ ಮಾಡಿದ್ರೆ ಎಲ್ಲ Cl ಇರಬೇಕು. That is homolyptic. Means environment same ಇರಬೇಕು. hetero means different. For example, one 4CN ಇದ್ರೆ ಇನ್ನೊಂದು remaining 2, it may be chlorine, it may be chloride, or it may be anything. Ligand ಯಾವುದು ಬೇಕಾದರೂ ಆಗಿರಬಹುದು. And next one is neutral complex, cationic complex, anionic complex. ಯಾವ ತರ ರೂಲ್ಸ್ ಫಾಲೋ ಮಾಡಬೇಕು? ಫಸ್ಟ್ ಯಾವುದಕ್ಕೆ ನಾವು ಪ್ರಿಫರೆನ್ಸ್ ಕೊಡಬೇಕು? ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಟ್ ಮೇ ಬಿ ನ್ಯೂಟ್ರಲ್ ಆಗಿದ್ರೆ ಅದರಲ್ಲಿ ನಂಬರ್ ಆಫ್ ಲಿಗ್ಯಾಂಡ್ಸ್ ಎಷ್ಟಿದೆ, ಆ ಲಿಗ್ಯಾಂಡ್ ನೇಮ್ ಏನು, ಆಫ್ಟರ್ ದಟ್ ಯಾವ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ ಯೂಸ್ ಮಾಡಿದೀವಿ, ಅಂಡ್ ಅದರ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಯಾವ ತರ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ನೌ. And then I will take one particular example and then after that I am going to explain it. And cationic complex means the complex carrying positive charge. Always you know, any formula means first always positive charge, later on negative charge. So complex only carrying positive charge means, so first one number of ligand, name of the ligand, central metal atom, oxidation state, lastly counter ion. Suppose anionic complex means complex carrying negative charge. So negative charge means first always counter ion, then once again same thing will repeat. These are all the rules you should know before naming the complex. Now I am going to give one general example in order to explain the naming. First one, ನ್ಯೂಟ್ರಲ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ನ ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡೋಣ ಯಾವ ತರ ನೇಮ್ ಮಾಡೋದು. ಫಸ್ಟ್ ಒನ್ ನಿಕ್ಕಲ್ CO 4 times. ಸಿ ಹೆಂಗ್ ಗೊತ್ತಾಗುತ್ತೆ this complex is neutral ಅಂತ? Here this side also means square bracket ಇದೆಯಲ್ಲ ಅದರ right hand side or else left hand side there is no counter ion. ಯಾವುದೇ ರೀತಿ counter ion ಇರಲಿಲ್ಲ ಅಂದ್ರೆ it's understood this one is neutral. Here above the square bracket there is no charge, positive nu illa, negative nu illa. This is also one of the indication. This is an example for neutral complex. Here how to name this? What are all the rules? See, number of ligands. First one, number of ligands means here, no doubt this one is a neutral complex. Which one is metal atom? CO is a metal atom? No, nickel is a metal atom. So this is CMI, central metal ion. And what about this CO? CO is nothing but, see, listen here, CO means carbonyl. This is example for ligand. What type of ligand? Neutral ligand. So it's a ligand. Correct alವಾ? ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಲ್ಲಿ ಮೆಟಲ್ ಯಾವುದು ligand ಯಾವುದು ಅಂತ ಗೊತ್ತಿರಬೇಕು. After that, number of ligands. How many ligands are there? See, which one is ligand? CO. How many ligands are there? 4. 4 means mono means 1, di means 2, tri means 3, tetra means 4. 4 ಗೆ ನಾವು ಏನಂತ ಯೂಸ್ ಮಾಡಬೇಕು? ಟೆಟ್ರಾ ಅಂತ ಯೂಸ್ ಮಾಡಬೇಕು. 4 ಗೆ ಏನು ಯೂಸ್ ಮಾಡಬೇಕು? ಟೆಟ್ರಾ ಅಂತ ಯೂಸ್ ಮಾಡಬೇಕು. And number of ligands over. Yesterday number of ligand 4 ಇದೆ, so I am using tetra. Name of the ligand. What is the name of the ligand? See, which one is act as a ligand here? CO. CO is nothing but, what is the name for that CO? Carbonyl. So tetra carbonyl. Tetra carbonyl. Now after that, CMI. Which one is the CMI? Central metal ion or else central metal atom. It's a nickel. So nickel. ಇದನ್ನ ನಾನು ನಿಕ್ಕಲೇಟ್ ಅಂತ ಬರೆಯಲ್ಲ. Why? It's not anionic complex. ಇದು anionic complex ಅಲ್ಲ. That's why I'm not at all using nickelate. Just nickel. And after that, oxidation state of metal. It should be in the open bracket. ಅದು open bracket ಅಲ್ಲಿ ಬರಿಬೇಕು. Square bracket ಅಲ್ಲಿ ಬರೆದ್ರೆ wrong ಆಗುತ್ತೆ. So nickel. What is the oxidation state of the nickel? How to calculate the oxidation state? That's oxidation state means ಯಾವ charge ಅಲ್ಲಿ ಇದೆ? Positive charge, negative charge. Means metal always carrying positive charge. But how much? +1 state ಅಲ್ಲಿ ಇದೆಯಾ? +2 na, +3 na? That is oxidation state. Here I don't know. ನೋಡಿದ ತಕ್ಷಣ ಪ್ರೆಡಿಕ್ಟ್ ಮಾಡಕ್ಕಾಗಲ್ಲ. So I don't know. That's why I'm going to represent it as X. X. This one is an example for, see, it's a neutral ligand. Neutral means no charge. No charge means 0. How to calculate the oxidation state? X. X for nickel. Along with nickel, carbonyl is there, no? That's why plus. And 0 multiplied by 4. Why multiplied by 4? 0 for one carbonyl group. How many carbonyl groups are there? 4 carbonyl groups are there. So 0 multiplied by 4 and overall charge. Any charges are there? Nothing. So 0. ಏನು ಚಾರ್ಜಸ್ ಇಲ್ಲ ಅಂದ್ರೆ ನಾರ್ಮಲ್ ಆಗಿ ನಾವೇನಂತ ತಗೋತೀವಿ? 1 ಅಂತ ತಗೋತೀವಿ. ಆ ತರ ತಗೋಬಾರ್ದು ಇಲ್ಲಿ. Here 1 ಅಂತ ತಗೊಂಡ್ರೆ this one is +1 or -1 or +1 ಅಂತ ಆಗ್ಬಿಡುತ್ತೆ. Then it become cationic species or else anionic species. That's why neutral anta ಹೇಳಿದ್ರೆ we should always use 0. And X 0 multiplied by any number is 0 is equal to 0. What is the oxidation state of the metal? 0. So it's 0. Too simple. It's 0. Now what is the name for that? For this particular compound? Tetra. Tetra means 4. Once again I am going to explain this. Tetra means 4. CO. Name of the ligand is carbonyl. And metal atom nickel. Oxidation state 0. How you come to know? Through calculation. Say tetra carbonyl nickel 0. It should be in open bracket. And one thing you just observe is, here first starting letter always capital, but after that the remaining letters are there, no? It should be smaller letter only. And one more thing, here there is no space. Once it started, once you bariyak shuru madidre space kodabardu. If you give the space, it's wrong. Okay. First example over now. Then second example. Iron CO 5 times. And last example, central metal atom is nickel. But in this example, central metal atom is iron. Iron 5 times carbonyl group. Iron 5 times carbonyl group. See, listen here. Iron is a central metal atom. No doubt in that. complex. So neutral complex. This is also neutral complex. And one more thing, keep it in your mind. This is homolyptic complex. We do homolyptic. Why? Here around iron, the surrounding ligands are there, no? All are carbonyl group only. That's why. How to name this? Here number of ligands. How many ligands are there? 5 ligands are there. 4 means tetra. 5 means penta. Capital letter P. Penta. Penta. And CO is nothing but here only. CO is nothing but carbonyl. Name for CO, carbonyl. What is the name of the central metal atom? Here central metal atom is iron, Fe. But you are not supposed to write ferrate. This one is neutral complex. Neutral complex ಆಗಿರೋದ್ರಿಂದ iron ಅಂತಾನೆ ಬರಿಬೇಕು. Ferrate ಅಂತ ಬರಿಬಾರದು. So iron. What is the oxidation state? Same thing. Last example I explained, no? Same as it is. You can calculate. I will treat it the oxidation state. I don't know, no? That's why I am representing X. This one is 0 and this one charge also 0. So X plus 0 into 5 is equal to overall charge 0. Now X plus 0 is equal to 0. So what is the X value? 0. So oxidation state in this case also 0. What is the name for this? Pentacarbonyl iron zinc. This is the name for the particular compound. And here just observe this. First letter only capital. The remaining letters all are small and there is no gap. This is the name for the pentacarbonyl iron zinc for this particular compound. Twice. Now, see, just observe, this is also an example for neutral complex. No doubt in that. This is also example for neutral complex. Why neutral complex? Because this side also no counter ion and this side also no counter ion. But here one twist is there. What is the twist here? See, in all the case, the last two example we discussed now, that is homolyptic complex. Homolyptic complex means only one type of ligand we are using. But here two types of ligands. This is central metal atom, no doubt, CMI. And this one also ligand and this one also ligand. This one is Cl. Cl means chlorido. Cl means chlorido. This is one type of ligand. How many Cls are there? 2 Cls are there. But PPH3, what is this PPH3? P means phosphorus. PH means phenyl. PH means phenyl. Phenyl is nothing but benzene ring. PH means phenyl means benzene ring. Here two types of ligands are there. Then what type of complex this is? This is neutral heteroleptic complex. Neutral means there is no counter ion. Heteroleptic means more than one type of ligands are present. That's why I say neutral, charge is 0, neutral, heteroleptic complex. Heteroleptic means two types of, around nickel sutta onde complex illa. For example, chloride illa, or else PPH3 ne nickel sutta illa. Nickel sutta Cl ide, PPH3 ide. Then how to name this? ಇವಾಗ ಯಾವ ತರ ನೇಮ್ ಮಾಡೋದು? Here two types of ligands are there, na? ಈ ಎರಡರಲ್ಲಿ ಯಾವುದನ್ನ ಫಸ್ಟ್ ನೇಮ್ ಮಾಡೋದು? That is a big question. According to alphabets. Alphabets ಪ್ರಕಾರ ನೇಮ್ ಮಾಡೋದು. Here this one is start with the C. This one is chlorido and this one is, what is the name for Cl? Cl ಗೆ ಏನಂತ ನೇಮ್ ಯೂಸ್ ಮಾಡಿದೀವಿ? ಇಲ್ಲೇ ಯೂಸ್ ಮಾಡಿದೀವಿ. This is understand. Here, central metal atom nickel, no doubt in that. It's a heteroleptic neutral complex. But how to name for this? Means first one, chlorine is there. What is the name for that? Chlorido. This one is 3-phenyl group. pH means phenyl. ನಾವು phenyl ಅಂತ ನೇಮಲ್ಲಿ ಬರೆಯಂಗಿಲ್ಲ, ಅದಕ್ಕೆ pH ಅಂತ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿದೀವಿ. 3-phenyl. 3 means triphenyl. 3 times phenyl groups are there. That's why triphenyl. Phenyl. This one is phosphorus. P means phosphorus. Phosphine ಅಂತ ಕರಿತೀವಿ. Triphenyl phosphine. And try to understand here. In both the case, this one is start with the C and this one is start with the P. According to alphabet ABCD, which letter will come first? C will come first or P will come first? Always C will come first. That's why I am going to give the preference for chlorine. Chloride ge first preference ಕೊಡಬೇಕು. ಯಾವ ತರ ನೇಮ್ ಮಾಡೋದು? See the rules. Number of ligands. Chlorido ಎಷ್ಟಿದೆ? 2 ಇದೆ. 2 means di. Chlorido. Start with capital. Di ಅಂತ ಬೇಕಾದ್ರೆ ಯೂಸ್ ಮಾಡಬಹುದು, bi ಅಂತ ಬೇಕಾದ್ರೆ ಯೂಸ್ ಮಾಡಬಹುದು. Dichlorido. 2 times chlorine ಇದೆ. That's why dichlorido. And this one is 2 times PPH3 ಇದೆ. But in this name PPH3 ಅಲ್ಲಿ ಏನಂತ ಇದೆ? Triphenyl. ನಾನಲ್ಲಿ by triphenyl phosphine ಅಂತ ಯೂಸ್ ಮಾಡಕ ಆಗಲ್ಲ. ಯಾಕೆ ಯೂಸ್ ಮಾಡಕ ಆಗಲ್ಲ? Because ligand ನೇಮ್ ನಲ್ಲೇ by tri ಅಂತ ಇದ್ರೆ ನಾನು ಅವಾಗ ಏನು ಮಾಡಬೇಕು? bis, tris ಈ ತರ ಯೂಸ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ligand ಅಲ್ಲಿ ಏನಾದರೂ ಇರಲಿ, ligand ಅಲ್ಲಿ biphenyl ಅಂತನಾದರೂ ಇರಲಿ, triphenyl ligand ನೇಮ್ ಅಲ್ಲೇ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಎಥಿಲೀನ್ ಡೈಅಮೈನ್ ಡೈ ಅಂತ ಇದೆ ಈ ligand ನೇಮ್ ಅಲ್ಲಿ. ಇದು ಎಷ್ಟು ಟೈಮ್? 2 times 3 times ಇದ್ರೆ ಅವಾಗ ನಾನು ಸಪೋಸ್ 2 times ಇದ್ರೆ ligand ಅವಾಗ ನಾನು bis ಅಂತ ಯೂಸ್ ಮಾಡಬೇಕು. 3 times ಇದ್ರೆ tris ಅಂತ ಯೂಸ್ ಮಾಡಬೇಕು. 4 times ಇದ್ರೆ ಟೆಟ್ರಾಕಿಸ್ ಅಂತ ಯೂಸ್ ಮಾಡಬೇಕು. 5 times ಇದ್ರೆ ಪೆಂಟಾಕಿಸ್ ಅಂತ ಯೂಸ್ ಮಾಡಬೇಕು. ಕನ್ಫ್ಯೂಸ್ ಆಗಬೇಡಿ, ಇನ್ನೊಂದ್ಸತಿ ಹೇಳ್ಕೊಡ್ತಾ ಇದ್ದೀನಿ. ಸಿ ಮೆಟಲ್ ಆಟಮ್ ಯಾವುದೇ ರೀತಿ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ, ಮೆಟಲ್ ಆಟಮ್ ಯಾವಾಗಲೂ ಒಂದೇ. ಬಟ್ ಲಿಗ್ಯಾಂಡು ಒಂದೇ ತರ ಲಿಗ್ಯಾಂಡ್ ಇರ್ಬೋದು ಅಥವಾ ಮೋರ್ ದ್ಯಾನ್ 1 ಟೈಪ್ ಆಫ್ ಲಿಗ್ಯಾಂಡ್ಸ್ ಆಲ್ಸೋ ಪಾಸಿಬಿಲಿಟೀಸ್ ಇದೆ. ಅದಕ್ಕೆ ಹೋಮೋಲೆಪ್ಟಿಕ್ ಹೆಟೆರೋಲೆಪ್ಟಿಕ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಂತ ಕರೆಯೋದು. ಸಪೋಸ್ ಹೆಟೆರೋಲೆಪ್ಟಿಕ್, ಹೋಮೋಲೆಪ್ಟಿಕ್ ಆದ್ರೆ ಡೌಟ್ ಬರಲ್ಲ, ಬಟ್ ಹೆಟೆರೋಲೆಪ್ಟಿಕ್ ಆದ್ರೆ ಲಿಟಲ್ ಬಿಟ್. ಸಿ ಹಿಯರ್ 2 types, ಮೋರ್ ದ್ಯಾನ್ 2 ಟೈಪ್ ಇರಬಹುದು, ಬಟ್ ಹಿಯರ್ 2 types ಇದೆ. First one is chlorido and second one is triphenyl phosphine. Ligand name alle tri anta ide. So first ಏನು ಗೊತ್ತಿರಬೇಕು? ಯಾವ ligand ನ first ಯೂಸ್ ಮಾಡಬೇಕು, first ಬರಿಬೇಕು according to the alphabets. ಯಾವುದು alphabetical order ಅಲ್ಲಿ first ಬರುತ್ತೋ ಅದನ್ನ first ಬರೀರಿ. Here chlorido C first ಬರುತ್ತೆ, C ಆದ್ಮೇಲೆ P ಬರೋದು. That's why dichlorido. Why I am using di? Because 2 chlorides are there. Now next one, this one also 2 times. Triphenyl phosphine ಎಷ್ಟು ಸರಿ ಇದೆ? 2 times ಇದೆ. ಬಟ್ ನಾನು ಇಲ್ಲಿ by ಅಂತ ಯೂಸ್ ಮಾಡಕ ಆಗಲ್ಲ. Why? ligand ನೇಮ್ ಅಲ್ಲೇ ಟ್ರೈ ಈ ತರ ಎಲ್ಲ ನೇಮ್ ನಂಬರ್ ಬಂದ್ಬಿಟ್ರೆ ನಾನು by ಅಂತೆಲ್ಲ ಯೂಸ್ ಮಾಡಬಾರ್ದು. ಸಪೋಸ್ 2 times ಇದ್ರೆ ಅದು bis ಅಂತ ಯೂಸ್ ಮಾಡಬೇಕು. 3 times ಇದ್ರೆ tris ಅಂತ ಯೂಸ್ ಮಾಡಿ. 4 times tetrakis, 5 times pentakis. Now see bis means 2 times ಇದೆ, 2 times it's a bis. ಅದನ್ನ ಓಪನ್ ನೆಕ್ಸ್ಟ್ ಬರೆಯೋದನ್ನ ಓಪನ್ ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ ಬರಿಬೇಕು. ಏನು what is the name for this? Triphenyl phosphine. Triphenyl phosphine. Close the bracket. Bis means 2 times triphenyl phosphine. Triphenyl phosphine ಅನ್ನೋದು 2 times ಇದೆ. Bis 2 times ಇದೆ. And after that now Number of ligands over, name of the ligands over. Central metal atom is nickel. Nickel. Then last one is oxidation state. How to calculate the oxidation state? See, listen here. It's an example for neutral. Sorry, it's an example for anionic ligand, Cl. That's why it carrying charge -1. Cl minus. Cl minus means what? It carry -1 charge. But what about the PPH3? PPH3, it's a neutral one. No charge, nothing. That's why PPH3 is a neutral, 0. It carry -1. I don't know for nickel. So, nickel X plus -1. 1 to Cl charge to minus. How many chlorides are there? 2 chlorides. So, multiply by 2. Plus, why? Along with chloride, PPH3 is there. So, plus 0 into 2 times. What is the overall charge? 0. Then what happened? X -1 into 2 -2 plus 0 into anything? 0. So, is equal to 0. X is equal to plus 2. X is equal to plus 2. What is the oxidation state of iron? Sorry, it's nickel. It's plus 2. Always we should represent it by using Roman letter. Roman numbers na use ಮಾಡಬೇಕು ನಾವಿಲ್ಲಿ. ನಾನು ಇದರ ಬರೆಯಂಗಿಲ್ಲ. Plus 2. No, I'm not supposed to mention like that. It's wrong. And this one is correct. It should be always in Roman number. Not like this. Hing bardru tappu. Yavattu just 2 lines. Suppose 3 idre idara, 4 idre like this. Then finally name over. What is the name for this? Dichlorido bis triphenyl phosphate. Triphenyl phosphate another 2 times there. Bis triphenyl phosphate nickel 2. This is the name for this. Still now what are all the things we discussed means it's only regarding homolyptic heterolyptic complex of neutral complex. But now it's a neutral complex. It's an example for neutral complex. Just try to understand. This one is complex ion, but complex ion containing simple ion also. Which one is simple ion? See, outside the square bracket ಹೊರಗಡೆ. It may be left hand side or it may be right hand side. ಏನಾದರೂ ಸ್ಪೀಸಸ್ ಇದೆಯಾ? Yes. Simple ion ಇದೆ. ಯಾವುದು? Cl. ಅದು 3 times ಇದೆ. So, it's not a neutral complex. ಇದು neutral complex ಅಲ್ಲ. Then what type of complex this is? It may be anionic or it may be cationic. Maybe. But which one is correct? Cationic or anionic? See, complex ion, first complex ion is there means it carry positive charge, it carry negative charge. Simple ion carry negative charge. Then what type of complex this is? This is cationic complex. This is cationic complex. Now, cationic complex, this is CO. CO means cobalt. Cobalt, this one act as a central metal atom. And around cobalt, how many ammonia groups are there? 6 ammonia groups. All ammonia groups are same. Then what type of complex? Homolyptic complex. Okay. Now, first you should split. How to split this? CO, NH3, 6 times plus Cl. And Cl 3 times is there, no? This 3 will come this side. Here 1 is there. Nothing means 1. Illi iradalla 1. Naan ille ittaradu. 1, this will come here. Next, first always carrying positive charge. Next one always carrying negative charge. First complex na split ಮಾಡ್ಕೊಳ್ಳಿ. Split is nothing but ionization. How to ionize? Complex ion separate, simple ion separate. Then first one, it may be positive or negative. First complex idre ಅದಕ್ಕೆ positive ಕೊಡಿ, next ಇರೋದಕ್ಕೆ negative ಕೊಡಿ. First simple ion idre simple ion ಗೆ positive ಕೊಡಿ, complex ಗೆ negative ಕೊಡಿ. First ಯಾವುದೇ ಸ್ಪೀಸೀಸ್ ಇದ್ರು ಅದಕ್ಕೆ positive ಕೊಡಬೇಕು. Yes. Now this 3 will come this side, this 1 will go this side. And after that, how many times complex are there? Only one time. That's why 1. How many times Cl? 3 times. So 3 Cl minus. This is the way we are going to ionize this. After that, how to name this? What type of complex this is? This is cationic complex. What are all the rules? Number of ligands. How many ligands are there? 6 ligands. How many ligands? 6. 6 means what? Hexa. 4 means tetra. 5 means penta. 6 means hexa. Hexa and NH3. NH3 is a ligand, na? See here. What is the name for NH3? Amine. NH3 means amine. Hexa amine. Means 6 time ammonia group. Hexa amine. What is the next one? CMine. Which one is the CMine here? Cobalt. I am going to write as cobalt only, not cobaltate. Why? This is cationic but not anionic. That's right. Cobalt. Then oxidation state. Oxidation state of CMine. How to calculate the oxidation state? Same. X. This is neutral, na? That's why 0. NH3 is nothing but 0. It's a neutral ligand. 0. So 0. This overall charge is plus 3. Plus 3. ಇದ್ರ ಜೊತೆ ಕೌಂಟ್ ಮಾಡಂಗಿಲ್ಲ. ಸ್ಪ್ಲಿಟ್ ಮಾಡಿರ್ತೀವಲ್ಲ ತಗೋಬೇಕು ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ. Then what happened? X plus 0 into 6. His pure ಮೇಲೆ overall charge ಏನಿದೆ? Plus 3 ಇದೆ. So plus 3. Once again I am going to explain this. X means I don't know, unknown. I don't know. I am going to calculate. Plus 0 into 6. 0 into 6 means it's a neutral ligand. So 0, 6 times neutral ligands are there. So multiply by 6 is equal to y plus 3. This, especially this cationic complex carrying plus 3 charge. That's why. Then X 0 into anything 0 is equal to plus 3. Then what is the oxidation state of cobalt? 3 plus 3. So Roman letter 3. After that, still now over. Then remaining counter ion. Which one is the counter ion? It's a chloride. ಇಲ್ಲೆಲ್ಲಾದ್ರೂ ಮೆನ್ಷನ್ ಮಾಡಿದ್ಯಾ ಕ್ಲೋರೈಡ್ ಎಷ್ಟಿದೆ ಅಂತ ಬರೀಬೇಕು. ನಂಬರ್ ಆಫ್ ಕೌಂಟರ್ ಅಯಾನ್ಸ್. ಆಫ್ಟರ್ ದಟ್ ಕೌಂಟರ್ ಅಯಾನ್ ನೇಮ್ ಅಂತ ಏನಾದ್ರು ಮೆನ್ಷನ್ ಮಾಡಿದ್ಯಾ? ನೋ, ಜಸ್ಟ್ ಕೌಂಟರ್ ಅಯಾನ್ದು ನೇಮ್ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಬೇಕು. ವಿಚ್ ಒನ್ ಇಸ್ ದ ಕೌಂಟರ್ ಅಯಾನ್? ಇಟ್ಸ್ ಎ ಕ್ಲೋರಿನ್. ಕ್ಲೋರಿನ್ ಅಂತ ಬರಿಬೇಕಾ? ಬರಿಬಾರ್ದು. ಇಟ್ಸ್ ಎ ಕ್ಲೋರೈಡ್. ವೈ? ಇಟ್ ಕ್ಯಾರಿ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಅಲ್ವಾ? ಇಟ್ಸ್ ಎ ಕ್ಲೋರೈಡ್. So is it clear? Now the name over. So hexamine, cobalt 3 chloride. This is the name for this particular compound. This is an example for cationic complex. Now next, anionic complex. Anionic complex means, I will take one example. K4 Fe CN6. This is example for anionic complex. How you come to know it's an example for anionic complex? First, in order to understand that, you should split this. How to split this? K FeCN positive, negative. But this one is simple, this one is complex. Complex carrying negative charge. That's why it's an example for anionic complex. And see here, this side 4 is there, this 4 will go here. So minus 4. And here nothing means 1. 1 will come here, plus 1. How many times potassiums are there? 4 times. So 4K plus. And this one is 1 time, na? That's why. Then what rule we are going to apply means anionic complex rule. First counter ion. Which one is the counter ion? Potassium. They didn't ask how many counter ions are tetra potassium. No. We are not supposed to write like that. So tetra potassium, sorry. If I write like this, tetra potassium, it's wrong. Why? They didn't ask how many potassium, how many counter ions are there. So, just I am going to mention the name of the counter ion. We start with capital P. Potassium. Here potassium is the counter ion. After that, number of ligand. How many ligands are there? 6. 6 means hexa. So potassium hexa. Cn means is an example for anionic. That's why cyanido. Hexacyanido. Hexacyanido means 6 times cyanide group. That's why hexacyanido. And which one is that? Central metal atom. Next one, central metal ion. Iron is the central metal. But shall I write iron as it is? No. Why means, see, just observe here. Name in anionic complex. Anionic complex alli enagutte metal name iron idre it becomes ferrate. Normal neutral and cationic, I just use iron as it is. But in anionic complex, the name become ferrate. Careful agiri, ferrate. What is oxidation state of the iron? I don't know. I am going to calculate now. I don't know for iron. X. This is -1. Why -1? Cn -1. It carry -1 charge. So -1. Now just calculate x plus -1 into 6 times. -1 for 1 Cn. How many Cns are there? 6. So -1 into 6 is equal to overall -4. Overall -4. So x -6 is equal to -4. This side -6 is there. It's there in left hand side. It will comes to right hand side means -6 become +6. So x is equal to -4 plus 6. Then what happened? X is equal to -4 plus 6. It become +2. It become +2. So +2 means you know Roman letter 2. Ferrate 2. That's it. Oxidation state is ferrate 2. So what is the name? Potassium counter ion, potassium hexacyanido ferrate 2. This is the name for this. Now I just changed that. Here instead of 4, suppose if I use 3, what happened? Everything same. Everything same. But instead of 4, I just use 3. Then what happened? This 3 will come this side. 3 minus or -3. Then 1 will come this side. 3 times potassium. See? 3K plus. And this one is 1 time. Huh? So 1. Then how the name is different from the previous one? Previous one in the name yav tara differ agutte. It's very simple. See, same rule. Why? This is also example for anionic complex. So potassium potassium hexacyanido, potassium hexacyanido. Same. Iron become ferrate. Ferrate. Here. What is the oxidation state for this particular compound? I am going to calculate now. X, iron I don't know X, plus minus 1 into 6 is equal to overall charges minus 3, but in previous case minus 4. So minus 3. Then what happened? X minus 6 is equal to minus 3. So X is equal to minus 3. This minus 6, if it is in left hand side, it comes to right hand side, means it becomes plus 6. X is equal to plus 3. So Roman letter 3. Simple. In previous case, potassium only, hexacyanido only, ferrate only. But previous case plus 2, but here plus 3. What it indicates? Iron plus 2 means ferrous state. Iron plus 3 means ferric state. If I give this example, then if you mention 2 plus 2, then what happened? The entire complex wrong. Next, one more example. See, chromium is there. Chromium is a central metal ion, no doubt in that. And that this one is amine, ammonia group, and that is H2O water. What type of complex this is? This is first you should try to understand. This one is anionic, neutral or cationic. Just split this. How to split this? Cr NH3 tries H2O tries. I just split this plus Cl. Correct now? Now 3 first always carry positive, then negative. How many is this? 3 is there, no? This 3 will come this side, this 1 will go this side. How many chlorides are there? 3 times. How many complex are there? Only 1 time. So I just split it, I just ionized the complex. Then what type of complex this is? This is cationic complex. This is cationic complex. Now, which rule you are going to apply? Cationic complex rule. What is the first one? Number of ligand. Here one twist. Here only one type of ligands are there. 2 types of ligands are there. First one is amine and second one aqua. If it is heteroleptic complex, you know, according to alphabets, we are going to give the priority. But here, both also start with A. Then, which one will come first? Amine group is first is there, that's why shall I write first? No, it's not like that. If both alphabets start with the same alphabet, if both ligands start with same alphabet, then just observe the second letter. Here first letter, second letter is M, here second letter is Q. First M will come, then Q. That's why we should give the first priority for amine, second priority for aqua. Simple. And how to name that? How many amine groups are there? 3. That's why tri-amine. How many aqua groups are there? 3. That's why tri-aqua. 3 amine groups. That's why tri-amine. 3 aqua groups. That's why tri-aqua. And number of ligand, name of the ligand, over, CMI, central metal atom. Which one is the central metal atom? Chromium. Shall I write chromate or chromium? Only chromium. Why? It's cationic. That's why chromium. What about the oxidation state? I don't know. I am going to calculate. X. Amine and aqua both are neutral complex. So 0, 0. X plus 0 into 3 plus 0 into 3 is equal to what is the overall charge? Plus 3. Plus 3. So X 0 plus 0, 0 only is equal to what is the oxidation state? Plus 1, 2, 3 plus 3. And what is the counter ion? Chloride. Chloride. Then what is the name for this particular compound? Triamine, triaqua, chromium 3 chloride. Now next one. See, this is a very important and special type of example. Just try to analyze this. Here, two types of complex are there. In normal previous case, one complex ion, only one complex ion, it may be positive or it may be negative. But the another one is simple ion. But here, both are also complex. How to split this? Very simple. Normal splitting. First is there, no? That's why AgNH3 twice and then AgCN twice. First always carrying positive, second always carrying negative. Here I can't say this is an neutral, this is cationic or this is anionic. Why? Because here both positive and negative charge containing species are complex only. That's why normal same procedure only. See, I will explain how. See, this is positive, this is negative. Why only one positive? Here also one is there, here also one is there. That's why one positive, one negative charge. Simple. First, I am going to name for cationic species. How to name for this? This is 2. 2 means di. NH3 is a ligand. So, diamine. This is cationic complex. Cationic complex rule. Number of ligands 2. That's why di. Name of the ligand amine. C-amine. Central metal atom. Central metal atom is Ag. Ag means silver. Correct, no? Diamine, silver, and oxidation state of central metal ion. What is the oxidation state of the central metal ion? I don't know. I am going to calculate X. It's a neutral, na? So 0. So X 0 into 2, 0. Overall charge plus 1. So X is equal to plus 1. I am going to mention the oxidation state plus 1. Now this cationic complex over now. No counter ion. This is counter ion, but counter ion itself is complex. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಅದು counter ion. But counter ion simple ion ಆಗಿಲ್ಲ, complex ion ಆಗಿದೆ. ಯಾವ ತರ ನೇಮ್ ಮಾಡೋದು? This is anionic complex. Just follow this anionic complex. Counter ion already name ಮಾಡಾಯ್ತು. This is counter ion na, counter ion named. Over, finish. Then number of ligands. How many ligands are there? Di. Cn means cyanido. Dicyanide. Silver Ag. This one also Ag, but I am not supposed to write Ag. Anionic complex. What is the Ag name? Silver name. Argentate. So I am going to use argentate. Argentate. What is the oxidation state of silver? I am going to calculate now. X. I don't know for this silver oxidation state. This silver to calculate agide. Confuse agbedi. Now this one minus 1. X minus 1 plus minus 1 into 2 means Two cyanido groups are there. One cyanido is -1. Two cyanido means multiply by 2. Is equal to -1. What is the overall charge? -1. Then what happened? X minus 2 is equal to -1. This 2 from left hand side to right hand side means it becomes x minus 1 plus 2. X is equal to plus 1. Then what is the charge? Oxidation state 1. Simple. Just try to understand. In previous case, one simple ion ittu, one complex ion ittu. But here, both are complex. First, we are going to ionize this. This is positive, this is negative. Positive complex, negative complex. Ashte. Positive complex andre, this rule apply madi. Cation. Number of ligands is diamino, silver, oxidation state 1. And for this, counter ion itself is complex. That is complex? Anionic complex. This rule apply madi. Counter ion, this counter ion yadu name madagoytu. Finish. Next one, dicyanide argentate 1. Too simple. Now, it's too simple. It's very, very easy. But it looks like a little bit bigger one. In examination, they may give like this or else similar one. Same complex. This complex. That is how to represent CO. Instead of this, idra badlige En. I just explained it. See, CH2, CH2, NH2, NH2. It's nothing but En, ethylene diamine. So, En tries to SO4. Both also correct. They may give like this or else they may give like this. Both also correct. Usually they will give like this only. See, now how to name this? It's very simple. Now, just split this. First, yaudadu split madadana kalpkoli, ionize madadana kalpkoli. How to ionize this? CO En3SO4. Correct now? Simple splitting. First, always positive, then negative. Here 2 is there, no? This 2 will come this side. -2. Here 3 is there, no? This 3 will come this side. 3. It's too simple. It's too simple. See, first split ಮಾಡ್ಕೊಳ್ಳಿ. ಇಲ್ಲಿ 2 ಇದೆ, ಅದು ಇಲ್ಲಿ ಕಳಿಸಿ, ಇಲ್ಲಿ 3 ಇದೆ, ಇಲ್ಲಿ ಕಳಿಸಿ. First always positive, next always negative. ಅಷ್ಟೇ. ತುಂಬಾ simple. Then what type of complex this is? Complex with the simple. Complex carrying positive, then cationic. This is cationic complex. Number of ligand. How many ligands are there? 3. 3 means tri. Wait, I will explain. 3. En. En means what? Ethane 1,2-diamine. Ethane 1,2-diamine. Correct? 3 times ethylene diamine means ethane 1,2-diamine group ಇದೆ. ಅದರಲ್ಲಿ ಟ್ರೈ ಅಂತ ಯೂಸ್ ಮಾಡಬಾರದು. Why I am not going to use tri? Because ethane 1,2-di ligand name ಅಲ್ಲಿ di, tri, tetra ಅಂತ ಬಂದ್ರೆ ಏನಂತ ಹೇಳ್ಕೊಟ್ಟಿದ್ರೆ, suppose 2 times ಇದ್ರೆ bis ಅಂತ ಯೂಸ್ ಮಾಡಬೇಕು, 3 times ಇದ್ರೆ tris ಅಂತ ಯೂಸ್ ಮಾಡಬೇಕು. How many times? 3 times. That's why this become tris, not tri. Tri ಅಂತ ಬಂದ್ರೆ wrong ಆಗುತ್ತೆ. It become tris. Tris ethane 1,2-diamine. Tris ethane 1,2-diamine. Why I am not going to use tri? Because ligand in itself it contains diamine. Di ಅನ್ನೋ ನೇಮ್ ಇದೆ. ಲಿಗ್ಯಾಂಡ್ ಅಲ್ಲೇ ಡೈ ಟ್ರೈ ಟೆಟ್ರಾ ಅಂತ ಇದ್ರೆ ಅವಾಗ ನಾವು ಈಚೆ ಬಿಸ್ ಟ್ರಿಸ್ ಟೆಟ್ರಾಕಿಸ್ ಈ ತರ ಯೂಸ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ವಾಟ್ ಹ್ಯಾಪನ್, ಲಿಗ್ಯಾಂಡ್ number of ligands over name of the ligand over central metal atom is cobalt. Cobalt, central metal atom is cobalt. Now I am going to calculate oxidation state. X is a neutral, na? That's why 0. It's a neutral, that's why 0. So X 0 into 3 0 overall plus 3. X is equal to plus 3. So cobalt 3. Cobalt 3. What is the counter ion? Sulfate. Sulfate. Then what is the name for this? Tris ethane 1,2-diamine cobalt 3 sulfate. Very simple. It look like big, but once if you understand the rules, it's very easy. Here, see, 4 examples here. You just try in your home. See, just I will give the clue. See, first one here, complex here. Complex irodrinda, this is example for cationic complex. ನೀವು cationic complex ಗೆ ಏನು ರೂಲ್ ಅಪ್ಲೈ ಮಾಡ್ತೀರಾ ಅದು ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಇದು ತುಂಬಾ ಸಿಂಪಲ್ ಆಗಿದೆ, ಈಸಿ ಇದೆ, just try it once. And this one is example for anionic complex. Ekandre complex carry negative charge. And one more thing here, the ligand is there, no ligand, C2O4. What is this C2O4? C2O4 is nothing but here. Just try to understand it. Here, C2O4. See, 1, 2, carbon atom 2, O4, O4, 2 minus. It carry -2 charge. Oxidation state ಕಂಡುಹಿಡಿಯುವಾಗ ತುಂಬಾ ಕೇರ್ಫುಲ್ ಆಗಿರಿ. Just try it once. See, here C2O4 means this is oxalato. Oxalato C2O4 ಅಂತ ಬರ್ತಿರೋದು. ನೆನಪಿಟ್ಕೊಳ್ಳಿ, oxalato. ಅದರ ಚಾರ್ಜ್ -2 ಇರುತ್ತೆ. -2 into 3 ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ. And this one is Hg. Hg means it's a counter ion. ಯಾವ ತರ ಬರೀತೀರಾ? ಮರ್ಕ್ಯೂರಿ ಅಂತಾನೆ ಬರೀಬೇಕು. ಸಿಂಪಲ್ ಅಯಾನ್ ನೇಮ್ ಅದು. ಸಿಂಪಲ್ ಅಯಾನ್ ಯಾವುದು ಇದರಲ್ಲಿ? Hg. Hg ನೇಮ್ ಏನು ಅಂತ ಬರೀಬೇಕು? ಮರ್ಕ್ಯೂರಿ ಅಂತಾನೆ ಬರೀಬೇಕು. What is some simple ion name here? Mercury. Hg means mercury. And SCN means it's a thiocyanate. Simple. It's not cyanido. It's a thiocyanate. 4 times is a tetrathiocyanate. Simple. Calculate the oxidation state. This one is very simple. This is example for anionic complex. Anionic complex means this is also, this one also. The chromium become chromate. Cobalt become cobaltate. Nickel become nickelate. Just try to solve this. Try to name for this particular compounds. Then you can understand better. Then after this, still now, if they will give the formula how to write, the name, how to nomenclate that. But now, if they will, instead of the formula, if they will give the name, then how to write the formula? They may ask in examination, they may give formula, or else they may give name. If they will give name, you should write the formula. If they will give formula, you should write it. Ulta also possible. Now, give the name. Instead of the formula ಬದಲಿಗೆ ಏನು ಮಾಡಿದ್ರು? ನೇಮ್ ಕೊಟ್ಟರು. ಉಲ್ಟಾ. ಇವಾಗ ಯಾವ ತರ ಇದನ್ನ ಫಾರ್ಮುಲಾಗೆ ಕನ್ವರ್ಟ್ ಮಾಡೋದು? Just see this name. Potassium trioxalato aluminate 3. Very simple. Potassium means K. Potassium means K. Tri means 3. ಅಂದ್ರೆ ಯಾವ ತರ ಬರ್ಕೊಳ್ಳೋದು ಅಂತ ಆಮೇಲೆ ಬರ್ಕೊಳ್ಳೋಣ ಫಾರ್ಮುಲಾಗೆ. ಫಸ್ಟ್ ನೇಮ್ ಅಲ್ಲಿ ಏನೇನಿದೆ ಅದನ್ನ ಒಂದು ಕಡೆ ಬರ್ಕೊಳ್ಳೋದು. ಪೊಟ್ಯಾಷಿಯಂ Tri means 3. Oxalato. Oxalato means ಇಲ್ಲಿ oxalato. ಯಾವ ತರ ಬರ್ಕೋಬೇಕು? C2O4. Correct na? C2O4. And aluminate. Aluminate means Al. Aluminium charge plus 3. Oxidation state. Correct na? Now, how to write the formula? First one, aluminate. Counter ion first ಗೆ ಇದೆ potassium ಅಂತ. Counter ion first ಗೆ ಇರುತ್ತೆ. ಎಲ್ಲಿ counter ion ಬರೋದು first ಗೆ? Then what type of complex this is? This is anionic complex. 1 2. This is anionic complex. First counter ion ಬರ್ಕೊಂಡ್ಬಿಡಿ. ಏನು ಬರ್ಕೋಬೇಕು counter ion ನ? K potassium ಬರ್ಕೊಂಡೆ. Then number of ligands is to 3. So C2O4 how many times? 3 times. Metal ಯಾವುದು? Al. ಇದು ಕರೆಕ್ಟಾ? ಮುಗ್ದೋಯ್ತಾ ಇಲ್ಲಿಗೆ? No. Here what is the charge? Plus 3. ನಮ್ಗೆ ಇಲ್ಲಿ ಏನು ಬರೀಬೇಕು ಅಂತ ಗೊತ್ತಿಲ್ಲ. So here 3 is the Roman letter, so plus 3 charge. It's a oxalate of charge ಏನಿದೆ plus 2 ಅದು ನಮಗೆ ಗೊತ್ತು ligand ಅಲ್ಲಿ. So minus 2. Then calculate the overall charge. Then plus 3 plus minus 2 into 3. Overall charge I don't know x. ನಾವು ಪ್ರೀವಿಯಸ್ ಕೇಸಲ್ಲಿ ಏನು ಮಾಡ್ತಿದ್ವಿ ಈ ಚಾರ್ಜ್ ಗೊತ್ತಿರ್ತಿತ್ತು ಈ ಚಾರ್ಜ್ ಗೊತ್ತಿಲ್ಲ ಅದಕ್ಕೆ ಎಕ್ಸ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಿದ್ವಿ ಈ ಕೇಸಲ್ಲಿ ಈ ಚಾರ್ಜ್ ಗೊತ್ತಿದೆ ಬಟ್ ಈ ಚಾರ್ಜ್ ಗೊತ್ತಿಲ್ಲ ದಟ್ಸ್ ವೈ ಐ ಆಮ್ ಟ್ರೀಟೆಡ್ ಆಸ್ ಎಕ್ಸ್ ಎಕ್ಸ್ ದೆನ್ ಪ್ಲಸ್ 3 ಮೈನಸ್ 6 is equal to x. Then what is the x value? Minus 3. So overall charge is minus 3. Correct alva? Idu counter ion first ಗೆ plus irutte, idakke minus irutte. Formula ಬರಿಬೇಕಾದ್ರೆ ಏನು ಮಾಡಬೇಕು? minus ಇಲ್ಲಿ 3 ಇರೋದು ಇಲ್ಲಿಗೆ ಬರುತ್ತೆ, ಇಲ್ಲಿ 1 ಇರೋದು ಇಲ್ಲಿ ಬರುತ್ತೆ. So what is the formula? K3Al O4 tries. Simple. Very simple. Once again I am going to explain this. Potassium means K, tri means 3, oxalato means formula. Oxalato C2O4. Aluminium means Al plus 3 state ಇದೆ. ಇದು ನೋಡಿದ ತಕ್ಷಣ ಗೊತ್ತಾಗುತ್ತೆ ಇದರಲ್ಲಿ ಕೌಂಟರ್ ಅಯಾನ್ ಫಸ್ಟ್ ಇರೋದ್ರಿಂದ ಇಟ್ಸ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ಅನಯಾನಿಕ್ ಸ್ಪೀಸೀಸ್ ಅಂತ. ಸೊ ಪೊಟ್ಯಾಷಿಯಂನ ಬರ್ಕೊಳ್ಳಿ, ಸ್ಪೀಸೀಸ್ ಅಂದರೆ ಕಾಂಪ್ಲೆಕ್ಸ್ಗೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇರೋದ್ರಿಂದ ನೆಕ್ಸ್ಟ್ ಬರ್ಕೊಳ್ಳಿ. ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಐಟಮ್ ಯಾವುದು? ಅಲ್ಯೂಮಿನಿಯಂ, ಆಕ್ಸಾಲೇಟ್, ಲಿಗ್ಯಾಂಡ್. ಇದ್ರ ಚಾರ್ಜ್ ಏನು? -2. ವೈ? ವಿ ನೋ ದಟ್. ಇದು ಫಾರ್ಮುಲಾದಲ್ಲೇ ಇದೆ, ನೇಮಲ್ಲೇ ಇದೆ +3 ಅಂತ. ಸೊ +3. ಇವಾಗ ರಿವರ್ಸ್ ಇದೆರಡನ್ನ ಯೂಸ್ ಮಾಡಿ ಇದನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ. ಇಲ್ಲಿ -3 ಇದೆ, -3 ದಿಸ್ 3 ಇಲ್ಲಿ ಬರುತ್ತೆ. ನಾವು ಲಾಸ್ಟ್ ಅಲ್ಲೆಲ್ಲ ಏನು ಮಾಡ್ತಿದ್ವಿ? ಸ್ಪ್ಲಿಟ್ ಮಾಡಿ ಇಲ್ಲಿರೋದನ್ನ ಇಲ್ಲಿ ಕಳಿಸ್ತಿದ್ವಿ. ಇವಾಗ ಇಲ್ಲಿರೋದನ್ನ ವಾಪಸ್ ರಿಟರ್ನ್ ತಗೋಬೇಕು. ಸೊ K3Al C2O4 tries. This is the formula. This is the way. Just try in your home. ಎಲ್ಲ ಫಾರ್ಮುಲಾಸ್ನು ಬರ್ಕೊಂಡು ಅದಕ್ಕೆ ನೇಮ್ ಮಾಡೋದಕ್ಕೆ ಟ್ರೈ ಮಾಡಿ. ನೇಮ್ನ ಬರ್ಕೊಂಡು ನೆಕ್ಸ್ಟು try to write the formula for that. Next example. See, it look like little bit big, but too easy. Tetra means 4. First I will read the name. Tetraamine aqua chlorido cobalt 3 chloride. See, tetra means 4. Amine means NH3. Amine. Aqua means water, H2O. Chlorido means Cl. Cobalt means CO. Cobalt charge plus 3. Chloride means first ಗೆ number of ligands ಇದೆ. Number of ligands. See, ಇಲ್ಲಿ counter ion first ಇದೆ. But number of ligands ಇದೆ ಎರಡರಲ್ಲೇ ಬರುತ್ತೆ. Means it may be neutral complex or it may be cationic complex. Suppose ಇದು neutral ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟಿಗೆ ಎಂಡ್ ಅಪ್ ಆಗಬೇಕಿತ್ತು. ಬಟ್ ಅದು ಮುಂದೇನು ಇದೆ ಅಂದ್ರೆ ಇಟ್ಸ್ an example for cationic complex. It's an example for cationic complex. It is an example for cationic complex. Too simple. It's an example for cationic complex. Now, just follow the rules. Number of ligands. But here 3 ligands are there. One amine, second one water, third one chlorido. So, cationic complex na positive. Next counter ion is chloride minus. Simple, too simple. Now first one tetraamine means amine group 4 times. Yes, over. Aqua, water, H2O. Chlorido, Cl. Cobalt plus 3 state ಇದೆ ಅದನ್ನು ಮೆನ್ಷನ್ ಮಾಡ್ಕೋಬೇಕು plus 3. It's a neutral 0. Water also neutral 0. But chloride, it's not neutral. It carry -1 charge. Overall, I don't know this X. Yes, that is positive only. But +1 charge or +2 charge, +3, I don't know that. That's why I am going to mention as X. Now, +3, 0 into 4, 0, 0 into 1, 0, -1 into 1, -1 is equal to X. Next, -1 plus 3, it becomes +2 is equal to X. Then what is the X value? +2. X value is +2. This 2 will come this side and this one will come this side. Then what is the final formula? CO NH3 4 times H2O Cl Cl2. This is the final formula. Final formula ಬರೆಯೋದಕ್ಕೂ ಮೊದಲು ಈ ತರ ಬರ್ಕೋಬಹುದು ನಮ್ಮ ರೆಫರೆನ್ಸ್ಗೆ. ಬಟ್ ಫೈನಲ್ ಫಾರ್ಮುಲಾದಲ್ಲಿ ಇದು +3, ಇದು 0, ಇದು 0 ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಬಾರ್ದು. Is it clear? Just try to solve some other examples. Understood? Today, especially in this session, now we come to know how to name the coordination complex. First, you should know ligand names. It may be neutral ligands or it may be anionic ligands. Neutral ligands means it never ever carry any charges, but it contains lone pair of electron. It donates the lone pair of electron towards the electron deficient metal atom. Suppose metal atom name in the anionic complex is little bit different. It ends up with ATE. And after that, homolyptic complex, heterolytic complex, you should know that. And then neutral complex means what are all the rules we should follow. Cationic means how. Anionic means how. You just know this. Once if you practice, it's too easy. Then just try to solve some other examples. If you have any doubt, first you should understand these rules. Rules na first ಚೆನ್ನಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. Rules ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ಮೇಲೆ solve ಮಾಡಿ. Then it's little bit easy. First ಗೆ solve ಮಾಡಿದ್ರೆ 101 doubt ಬರುತ್ತೆ. First try to understand the rules. ಏನಾದರೂ doubt ಇದ್ರೆ you can post the questions. Try to solve some more examples. Examples collect ಮಾಡಿ, try to solve, try to answer that. Try to name the compound.